Hello everyone, myself Dr. Santami Kundu. I welcome you all to this lecture of soft computing techniques. This is the third lecture of module 11. So in this chapter, we are studying the method of rule generations. So today we will solve few questions uh, for the rule generations. So here is one example is there, that is some about the weather conditions. So here there are 14 objects, objects 1 to 14. The attributes are outlook. So there is values are sunny, overcast means cloudy, some rain, sunny, rain, etc. Another attribute is temperature, here something hot, mild, cool, etc. Humidity is high, normal, high. Windy, that is A4, sometimes false, sometimes true. And decision is negative positive, so n for negative, p for positive. So here if we study the object 1, the outlook attribute value is sunny, so object 1 is sunny, hot, high, false, n. Similarly for object 2 is outlook is sunny, temperature is hot, humidity is high, wind is true, this is n. So let's C equal to the set of all conditional attributes, so that is a1, a2, a3, a4. So indiscriminate relations of the C, see here all are different. So that is 1, 2, 3, 4, 5, 6, 7, 8. So all separate equivalence classes. So indiscriminate relation of D, so that is U by D. So for N, it is 1, 2, 6, then 8, then 14. So that is for N, and remaining are for P, that is for positive, as 3, 4, 5, then 7, 9, 10, 11, 12, 13. So these are the indiscriminate relations. We need to find now the boundary region. So for here we assume x1 for the n, and this is for n, and this is for p. So the lower approximation on the base of x1 is you will get 1, 2, 6, 8, 14, and for x2, that is 3, 4, 5, 7, 9, 10, 11, 12, 3. So positive reason of u by d with respect to attribute c, that is with respect to all attributes, are union of x belongs to u by d, all lower approximations will get the whole things. Similarly, if we calculate the union x belongs to d upper, or the union of all upper approximations, you will get the same thing. So our boundary region is 5. Now again is that if we use discernibility matrix and discernibility functions, we will find the reduct 1, which is a1, a2, a4. Reduct 2 is a1, a3, a4. So core is a1 and a4. So now on the basis of the reduct 1, we have this table. So this is table for reduct 1. So you can write this is table for reduct 1 for reduct 1. So there are 14 elements, but uh, we merge two rows. We merge R4 and R10 in a single row, and R3 and R13 in a single row, because here A3 is missing. So A3 is missing. So if the R4 is rain, mild, false, peak, so check R4. So R4 is rain, mild, then this is high, false, and P. So this is the R4, and R10 is in the place of high you will get normal. So these two are merged. So that is single row R mild, false, P. Similarly, we merge R3 and R13, where R3 is overcast, hot, high, false, P. Here R13 is overcast. In place of this high, this written is normal. So this is overcast, hot, normal, false, P. So these are not present. So we can merge these two. So ultimately we have the 12 rows here. Similarly, this is the table for reduct 2. Table for reduct 2. So here that a1, a3, a4, so a2 is missing here. So here we also merge to these two row 5 and 10 and 8 and 1. So 5 is rain, cool, normal, false, P. So you can check 5 rain, cool, 5 is rain, cool, normal, false, P. Then is a rain, mild, normal, false, P. So we make this is the single row, and also 1 is sunny, hot, high, false in, and 8 is sunny, mild, high, false in. So we also match this. So ultimately we have the table 12 rows. So now some values are after merging, after merge we have 12 rows for both the tables. Okay. So now here if we see that that sunny, hot, windy end, so check here sunny, hot and windy. So if we check here, then we will find that for the reduct 1, see sunny, hot, these two may be written as star because sunny hot n, so this may be written as r. Similarly, where is overcast, so see overcast means p, overcast means p, overcast means p, so there no need to that these things. So we can write the table, so this may be written as sunny, hot, windy n, then overcast, these two star, p, rain, star, false, p. So temperature may be anything, but if rain and false, then we'll get p, rain and true, then we'll get n. Similarly, sunny, mild, false, n, then you can write like that star, cool, false, p, and star, mild, true, p. So this can be written from the another table is that this is sunny, high, star n, overcast, star p. This is from reduct 2, rain, star, false, p. So there is only 5 rows. Initially there are 7 rows, so we may write it like this is reduct 2 is better because here we have only 5 rows. So reduct 2 is better as it has less number of rows. Now we can find the rule here. So rules are there that if outlook is sunny and humidity is high, then n. So if outlook is sunny, humidity is high, then n. If overcast, then p. If outlook is rain and windy is false, then p. If outlook is rain, windy is true, then n. If outlook is sunny, humidity is normal, then p. So we have the five rules. So from the big tables, we generate these 5 rules. So let's try for another example. So this is our known table. So this patient, 6 patients are there. So these are the objects. As you know, in row, these are the objects. So these 3 are conditional attributes. These 3 are conditional attributes, and this is decision attributes. So here P1 is headache is no, muscle pain is yes, temperature is high, flu is yes. For P2, headache is yes, muscle pain is no, temperature is high, flu is yes. For P3, headache is yes, muscle pain yes, temperature very high, flu is yes. For P4, no, yes, normal, no. For P5, headache is yes, muscle pain is no, temperature is high, flu is no. For P6, headache is no, muscle pain is yes, temperature is very high, flu is yes. So here let's see equal to the set of all attributes headache, muscle pain, temperature. So indissimilarity relations for us. C is P1, see P2 and P5 are the same thing. Yes, no, high. Yes, no, high. So that is P2, P5, then P3, P4, P6. So indissimilarity of D. So U by D. So that is for yes, P1, P2, P3, P6 for yes, and P4, P5 for no. So here is flu yes, flu no. So here the positive region, that is union of x belongs to u by d, all lower approximation. So that is positive region of the partition U by D with respect to attribute C, that is all attributes, is P1, P3, P4, P6. If you calculate the U belongs to X belongs to U by D for all, say, union of all upper approximations, you will get the whole set. So here boundary region is P2 and P5. So we need to eliminate the boundary regions. So we eliminate P2 and P5. Now you consider, as you know that this is the core attribute, so you consider one reduct, which is headache and temperatures. Okay, so you can calculate it from the discriminative matrix and function. So as you saw the question earlier, so we assume this is the reduct, headache and temperature. So 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 what I am saying that we eliminate the boundary region. So after boundary regions, we have four rows. Initially, we have six rows. So after deleting rows or of rows P2 and P5, we have this table. Now you consider deduct equal to headache and temperature. So we drop the muscle pain. So drop the muscle pain. So headache is no, high, yes. For P1, for P3, yes, very high, yes. For P4, no, normal, no. For P6, no, very high, yes. So this table can be rewritten as, we can rewrite the table as, for P1 no high yes, so no high yes. For P3 C very high yes, so that is yes no not matter. So we put a star here. So P3 star very high yes. For P4 is no, normal no. For P6 again star. So again we merge these two. So we have P1 no high yes. For P3 headache is star very high yes. For P4 no, normal yes. So rule 1 is that if headache is no, temperature is high, then flu is yes. If temperature is very high, flu is yes. If headache is no, temperature is normal, then flu is no. So these are the rules we got from the tables. Now, the next topic is that the generation of rules for missing attribute values of a data set. So there is some data set is there. So if some values are missing, suppose there are six cases, one, two, three, four, five, six. So blood pressure is high, that is unknown, unknown, high, unknown, normal. Chest pain here unknown, yes, no, unknown, yes, no. Cholesterol is high, unknown, unknown, high, low, unknown. Heart produce yes, yes, no, yes, no, no. So there is some attribute is missing here. So whenever there is some attribute missing, we need to fill the missing values. So fill the missing values is that we need to fill the missing values. So fill the missing values which appear maximum time. So we need to fill the missing values. So fill it the value which appear maximum time. So here maximum time is high appear. So we can fill it like high. So fill the values by which fill the value which appear maximum times. So you better write fill the value which appeared maximum time. So here maximum time is high appear. So we can write it high. We can write it high. So here yes maximum time. So two time yes, two time no. So fill it yes. Okay. So here high appeared two times, low is one time. So write it high. So this is the way to fill the missing values. Fill by the value which appeared maximum times. So after these values, a table will look like that, high, high, high. So everything is high here. I think everything except this is normal. So yes, no, yes, yes, no. So yes, no, yes, yes, no. Then first four are high, then high except one is low. So except one is low, everything is high here, and this is yes, no, yes, no, yes, no, no. So that is the complete tables. So we put the missing value by the value which appear maximum times. Now here we need to do the same process. So calculate the upper approximations, I mean the positive positive region, and that, so we need to calculate these things, that union x belongs to the partition u by d, union of all lower approximations. We need to find x belongs to u by d, the union of all upper approximations, then boundary region, etc. So let's see equal to blood pressure, chest pain, cholesterol, heart probe, and these conditional attributes. These are the object. So these are the constitutive decision attributes. That's a D written here. So write the C is the all conditional attributes. So blood pressure, chest pain, cholesterol. So in this designation of C, yes, high, yes, high, and yes, I. So 1, 2 for same, then 3, 5, and 6 are different. So now for decision u by d is 1, 2, 4, 3, 5, 6. So that is x1, this is x2. So you can write the lower approximation cx1 subset. So you'll get it 1, 2, 4, and for cx2 you'll get it 3, 5, 6. So union is these things, and for both the union of lower all approximations, union of all upper approximations will get the same thing. So there is nothing in boundary region. But here we need to merge it. So after merging, we have these things. So 1, 2, 4 is merging. So that we written 1. So high, yes, high, yes. Then 3 is blood pressure is high, chest pain is no, cholesterol is high, heart problem is no. For 5, blood pressure is high, chest pain is yes, cholesterol is low, heart problem is no. For the 6, blood pressure is normal, chest pain is no, cholesterol is high, heart problem is no. So we merge it. Now we need to the find the reduct. So to find the reduct, we need to find the disseminated matrix and disseminated function. So check it. So here disseminated, see this is same, this is no. So if I write here the disseminated matrix, so here I write it. The last column we need to delete. So write 1, 3, 5. So see 3 with 1, 3 with 1. If you compare, we'll get only chest pain is the different. So here we write the chest pain. Here we can write the chest pain. So I'm writing just chest pain. So similarly for 3, 5 to 3. So 5 to similarly 5 to 1, 5 to 1, there will be the same thing is there. So need to write it only the cholesterol, and 6 to 1 you need to write only that this is same. So blood pressure and chest pain. So and here you see interesting is that from 5 to 3 null set, then from 6 to 3 also the null set, because this is same, it's also this is same. So here we write something. So just check it in the next slide. So let blood pressure equal to x, chest pain is y, cholesterol is z. So x, y, z. So now 1, 3, 5. So compare 3 with 1. So only the chest pain is that is not same. So rest 2, x and z are same. So blood pressure and cholesterol is same for 3 and 1. Just check it. For 3 and 1, blood pressure, cholesterol is same. Only chest pain is not same. Now for 5 and 1. So 5 and 1. 5 and 1, everything is same, only the cholesterol, that is z. So we written here z. Now 6 to 1 we will get the blood pressure is different, chest pain is different, so it is x and y. So just check it. So x and y. So here the dissimilarity matrix is that y dot z x plus y. So you can write it y dot x plus y z y. So that is y z. So now this is the yz. So deduct is that chest pain and cholesterol. So need to keep the value of chest pain and cholesterol. So chest pain, yes, high, yes, and then no, high, no, yes, low, no, no, high, no. So need to march this 3 and 6. So march 3 and 6 here. So we'll get yes, high, yes, no, high, no. For 5, yes, cholesterol is low, and this is no. So now rule 1, if chest pain is yes and cholesterol is high, then heart problem is yes. If chest pain is no and cholesterol is high, then heart problem is no. Rule 3, if chest pain is yes and cholesterol is low, then heart problem is no. So this decision based on the given table, nothing else. The question is that here also one example. So here the missing values are there. So you try to solve these questions. So find rules or generate rules from this decision table, from the given decision table, from the given decision table. So this is one question, you try to solve it. So for the questions I give you a hint. So here see high appear 3 times, so here you write high. And yes appear 3 times, so write it yes. So again consider the boundary region. First find the boundary regions, eliminate the rows, then find disseminated matrix and the core, so find reduct, then write the rules. So this is the questions. So in today's class we have understood the rule generations. So question is that by using reducts find rules from any decision table which are given in the previous slides. So from any decision table of previous questions you can write any decision table of previous questions. So these are the references of today's class. Thank you.